Good morning, all.
Good morning.
Why students are taking that much time to join? Only 8 participants have been joined till now. In 5 minutes, I think everyone should join. I have sent this link on difference equation group also, as well as that your old group also.
Yes, ma'am.
Yes, joining now. Whether anybody tried that Tower of Hanoi game yesterday in Google? Or in your home, that rings game is there also, there you can try that game. Very interesting game. Okay, so shall we start now? 16. I think 33, total 33 members are there, no? So first chapter is just introduction, and in that some 6 to 7 applications of the real life applications of difference equations has been given. So I think we have finished 3 examples till yesterday.
Yes, ma'am.
First example in finance, second one was in physics, and third we have seen example of that Tower of Hanoi. So now we will see today another example, another 2 examples. Let's see. Okay, I will share now my screen. Let me take the screen. Okay. So can you able to see the screen? OneNote screen?
Yes, ma'am.
Aries, Aries equation, whatever I have written, lecture 4 real life examples. Example 1.4, Aries equation. You can see?
Yes, ma'am.
So I will start now. This is another example of difference equation, which is called Aries equation. So consider second order differential equation, x times y of x. So this is called as Aries equation, and this has many applications. This arises in electrical engineering as well as in physics also, while solving that Schrödinger equations. Okay, so we will see now how difference equations play important role in solving such type of Aries equation. Okay, so which type of differential equation it is? Second order ordinary differential equation, right? It is
Yes, ma'am.
second order ODE. Okay, it is not of with constant coefficients, right? Otherwise we might have solved easily. So I will use here now power series solution method. In your first semester in ODE, you might have learned power series solution method to solve various differential equations, right? We use power series solution method. whatever I am writing, can you able to see this?
Yes, ma'am. Yes, ma'am.
Just now I have written like that Aries equation y double dash of x is equal to x times yx, and then I written we use power series solution method. Okay, red pen I am using to write. So can I go ahead now?
Yes,
Can I
ma'am.
go ahead?
Yes, ma'am.
So in power series solution method, what we do, we consider yx is equal to summation k is equal to 0 to infinity some ak x raised to k. Usually these differential equations has solutions in terms of power series. So we are considering let yx is equal to this power series, infinite power series, k is equal to 0 to infinity ak x raised to k be solution of this second order differential equation. Consider or let be solution of equation 1. So if yx is equal to this one, now differentiating with respect to x, what I will get?
Y dash of x.
With respect to x, we get, what we get? Y dash of x is equal to what?
AK.
Yeah,
K is equal to 0 to infinity.
k is equal to 0 to infinity,
K into AK
k into ak
into
X to
x
K
raised
minus 1.
to K minus 1.
into
X raised to K minus 1.
k minus 1. Whether everybody agree with this or,
Yes.
Yes,
Yes.
ma'am.
or anybody has
Yes, ma'am.
another anything to correct? Check again.
Ma'am, k equals to 1 to infinity.
Yeah, who is saying this?
Pooja Rukde.
Yeah, okay, huh. So it should be k is equal to 1, not 0.
120.
Yeah. Why? Because if I expand this, let me use another pen. If I expand this, uh, what was my yx? It is k is equal to 0, means a0 x raised to 0 plus a1 x raised to 1 plus a2 x raised to 2 plus a3 x cubed, and so on. So if I differentiate with respect to x, x raised to 0 is just 1. Okay. So it is just constant a0. So differentiating a0 with respect to x, I will get here 0. Then a1 as it is, what is differentiation of x? It is 1 plus a2. What is differentiation of x square? It is 2 times x plus a3 as it is, and 3 times x square, and so on. Okay. So if I write in series form, then it will start from k is equal to 1 to infinity. Is that okay? K
Yes,
a
ma'am.
x raised to k minus 1. That is my y dash of x. Is that okay? Yes.
Yes, ma'am. Yes, ma'am.
So here it is k is equal to 1. I will erase this now. So what is double derivative now? Second order derivative. Again differentiate with respect to x. What I will get?
Y double dash of x.
Y double dash of x is equal to what?
Summation k from k
K from
1 to infinity.
2 to infinity.
K equals to 2 to infinity.
K
2 to infinity.
K
K
into
square.
minus
K square. A K.
A k
A K. X raised to.
k square a k
k minus
k minus.
X raised to. X raised to K minus 2.
Is it correct?
No, ma'am.
no ma'am.
Ma'am.
K square minus k
Into k minus 1.
K square.
Right.
K minus 1.
k square minus k in bracket a k x raised to k minus 2.
Yeah, so
K in bracket K.
k minus 1 a k
हाँ correct. X raised to k minus
yeah. Yeah, so that is my second order derivative. Now what I will do in equation 1, if we see, now I replace this y of x here and y double dash of x here. Value of y double dash of x, and y dash is absent in equation 1, so I won't keep that. So substituting these values in equation 1, we get substituting these values in equation 1, we get what we get. It is k to 2, no? K is equal to 2 to infinity k into k minus
into K minus
ak x raised to k minus 2
K minus
K minus 2.
x times y of x. Y of x is my k is equal to 0 to infinity ak
infinity.
x raised to k.
X
Is it okay?
X raised to K.
Yeah. And x if I take inside, because this summation is independent of x, so I can take inside. So I will get here k is equal to 0 to infinity ak x raised to,
K plus 1.
is it? So here
Yes, ma'am.
left hand side is k is equal to 2 to infinity k minus 1 ak x raised to k minus 2. Now our aim is to find that constants ak. So now I am having in left hand side also I am having power series, right hand side also I am having power series, but indices are different. Okay, here what are the indices? X raised to k minus 2, and here indices is
X
k plus 1.
K plus 1.
Of x is k plus 1. So if I want to equalize, means when I can compare coefficients, when two power series are equal, their coefficients are equal, right? Two power series are equal if and only if their coefficients are equal. So if I want to compare coefficients, first I need to make these indices equal. Okay. So if I
Yes,
want
ma'am.
to make left hand side indices as k plus 1, what should I replace here? My k should change to what? I want here k plus 1. So what should I do here?
K plus 3.
So if I change,
K plus 3 minus 2.
yeah, so k plus 3 minus 2, I will get k plus 1. So if I change k to k plus 3 in left hand side, so change, I will write, where is that? Changing indices k to k plus 3 in LHS only, okay? In LHS of equation 2. I will write, say this is equation 2. What we get? If I change indices, what I will get? here k is equal to 2 to
K
infinity.
plus 1.
So k will be what now? New k.
K equal to
So if
K
k
equal
is
to 3.
changing to k plus 3,
-1.
it will be
Minus 1
Minus
to
1 to infinity.
minus 1 to infinity.
-1 to infinity.
Infinity.
So
Infinity.
k will be, I am changing to k
K
plus,
plus 3
3.
here it will be
into
2.
K plus 2.
K plus 2. AK plus 3.
K plus 3
raised
x
to
raised to K plus 1.
1.
Is equal to right hand side as it is. Is it?
Yes, ma'am.
So is this step is clear? Whatever
Yes,
I am
ma'am.
writing
Yes,
properly
ma'am.
visible?
आपको हेल्प को
Yes,
बस
ma'am.
ma'am.
Writing,
Yes, ma'am.
some problem, but it's okay. I think you can able to understand what I am writing, no? Right? Yeah. So now you can see here I am having these are the coefficients of x raised to k plus 1, and here coefficient is just ak. Now if I compare the coefficients, so here it is k is equal to 0 to infinity, here it is k is equal to -1 to infinity. So if I change this to k is equal to -1, so for k is equal to, comparing coefficients now, for k is equal to -1, what will be this side? 2
2 into 1 a2 x raised to 0 1 into 1.
x to 0 means 1, right?
1.
So I am not writing that, which is equal to, what is the k is equal to minus term here? There is no term, na? K is equal to -1, it doesn't start here, right hand side.
0.
Is it? So it is 0.
0.
So here what I am doing here, I am comparing coefficients of x raised to k plus 1. Now when k is equal to -1, left hand side is 2 times a2, but right hand side is 0 for k is equal to -1, right? If I want to write this side as from k is equal to -1, what I will do? Just k is equal to -1 to infinity, 0 times ak x raised to not 0,
K minus 1. K plus 1.
not like that.
A minus
A2 equal to 0.
So here I can write, okay, differently. Here it will be like my k is equal to -1 term is 0. So 0 plus something. And that I can write as k is equal to -1 to infinity. Okay. So
Okay.
I am getting here 2 times a2 is equal to 2 times a2 is equal to 0. What this implies? A2 must
A2 is equal to 0.
A2 must be
0.
0.
Now for k is equal to 0 to infinity, if I now for k is equal to 0, 1, 2, 3, and so on. Coefficients will be, now I can compare coefficients. What will be coefficients then? Comparing coefficients, I will get k plus 3, k plus 2, k
Into K plus 2.
3 is
K plus 3 is equals to AK.
Okay.
so I am
Yes,
getting
ma'am.
here ak plus 3 is nothing but ak divided by
Divided by k plus 3 into k plus 2.
into k plus.
K plus 2.
So this is for k is equal to 0, 1, 2, 3, and so on. Is it? So if k
Yes,
is
ma'am.
equal to 0, what? So now you can see this is difference equation. Ak plus 3 is equal to ak. Means if I know values of a0 and a1, I can find all values of ak's. Is it? a2 is already 0. Now for k plus 3, k is equal to 0 if I substitute. For k is equal to 0, what I will get? A3 is equal to A0 divided by 3 into 2, na? 3 into 2. Is it? Everybody getting this?
Yes, ma'am.
What I am doing? So for k is equal to 0, 1, 2, 3, I am having this relation between coefficients. AK is this is the relation between the AK plus 3 and AK. So for different values of k, I will have different values. Now for k is equal to 1, what I am having?
A4
A4 is equal to A1 divided by 4 times 3, right? Now for k is equal to 2, what is A5? A5 is A2 divided by 5 times 4, right? But A2 already I am having A2 is equal to 0.
0.
So A5 is 0.
0.
Similarly for k is equal to 3. What I will get? K is equal to 3. I will get A6. A6 will be
3 divided by
A3 divided by 6.
6 into 5. 5.
3 is nothing but my A0 divided by into 2 into 6 into 5. Is it? A3 value I am substituting from here. Right?
Yes, ma'am.
This is my
Yes,
A3.
ma'am.
Now A3 I can write in terms of A0. Now A4 I can write in terms of A1. So whatever next values we will get, that I can calculate if I know A0 and A1, because A2 is already 0. Okay.
Okay.
Yeah. So
Yes, ma'am.
where is that? Where is? Yeah. So from this I can say change the color. A3n plus 2 is equal to what? A3n plus 2. What is my AK? It is of the form like this, no? A5. It will be
0, 0,
so I will get 0 for all
0.
n is equal to 0, 1, 2, and so on. Is it? Because
So
A
on.
is 0. A5 is 0. Then what will be next? 3,
8.
7, 8.
8.
8 will be 0 and so on. And remaining terms I can find in terms of A1 and A0. Is it?
And 0.
Yeah. So finally I can, so now I got for all values of k. I got this, just highlight this. This is my difference equation. This relation is also known as recurrence relation or difference equation. So calculating recursively values of A0, A1, A2, A3 and so on, I will get all values of AK plus 3 if I know A0 and A1. Okay, provided that I should know what is my A0 and A1. A2 is already 0. So if I know that A0 and A1, then all values of AKs I can calculate. Okay. Is that okay? Yeah.
Yes,
So
ma'am.
these AKs are these AKs are what? These are nothing but coefficients of this one, x raised to k, and that is my final solution. Okay. So we have we got that values of AK because we have considered this yx as a solution of this equation 1, right? So what is my final solution then? It will be in terms of A0 and A1. So I will write now that final solution therefore the required solution can be written as yx is equal to, now I will collect all the coefficients of a0. So 1 plus x cube divided by 3 into 2 plus, what is the next term, x raised to 6 divided by 6 into 5 into 3 into 2 plus, and so on, right? Next term is x raised to 9, right? X raised to 9 divided by something, okay, whatever may be the coefficient, and then plus a1 times what is the coefficient, x plus x raised to 4 divided by 4 into 3 plus x raised to 7 divided by 7 into 6 into 4 into 3, and so on, infinite. Okay.
Yes,
And
ma'am.
A2, whatever A2 terms are there, they are already 0. Okay. Is it? Here you can see. A3n plus 2 terms are 0 because A2 is 0. Okay. So only these terms will remain. Is that clear, this solution? This is the required solution of our Aries equation. And we have obtained this by solving difference equation or recurrence relation. This one. This relation. Is it? Now, you can see the solution converges because what is this relation we got here? AK plus 3 is divided by AK is nothing but 1 upon K plus 3 into K plus 2. No? What relation we got? Yeah, AK plus 3. If I write this as AK plus 3 upon AK, which is what I will get, 1 upon K plus 3 into K plus 2. So as K tends to infinity, it will tends to 0. So this
Yes.
1 upon K plus 3 into K plus
Yes,
2
ma'am.
will tends to 0 as K tending to infinity. So by ratio test, I can say this series solution converges. Is it? Because by applying ratio test, AK plus 3 upon AK, I am getting as tending to 0 as my K is larger and getting larger and larger. K tends to infinity. So I can say that the power series converges, the power series Yx converges for all values of x. Okay, is this clear to everyone, this solution? I will share all the same notes to you, okay?
Okay, ma'am.
Yeah. At least one person should reply, huh? Whatever question I am
Okay, ma'am.
asking, so that I will come to know everybody is following. Okay, so now we will go to next example, which is gamma function. Next example 5. 1.5 you say is gamma function. Watch minute. Gamma function. Everybody know gamma function and beta function?
Yes, ma'am.
Yeah.
Yes,
So what is
ma'am.
gamma
Yes, ma'am.
function? Which is represented by gamma of z.
Yes.
Is it? So what is gamma function?
Yes, ma'am.
The gamma function, gamma of z is equal to integration 0 to infinity e raised to minus
E raised to
t raised to
minus t
z minus
n
1
minus 1.
dt. This is my gamma function where z oh, sorry, where real part of z should be positive. Z is positive. This is the definition of gamma function. Is it? You might have seen in BSc third year or second year many properties of gamma function. Is it? If gamma
Yes, ma'am.
gamma of z is this one, what is gamma of z plus 1? What is gamma of z plus 1?
Integration 0 to infinity
0 to infinity
e raised to
T
minus t
Uh,
into t raised to z
raised to z
dt
dt.
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 Now I want to find
Okay.
relation between gamma z plus 1 and gamma z. So what I will integrating by parts to this gamma z plus 1. What I will get? Applying integration by parts. What I will get? Which function I have to take first?
T square.
Z as it is.
To z.
Square t raised to z.
T raised to z.
Raised to z as it is. LIT rule.
Raised to minus.
Exponential will be last.
Yes.
And what is the integration of e raised to minus t? Minus
E raised to minus t by
Minus e raised to minus t
this is from
from 0 to infinity
0 to infinity. Minus integration.
minus integration 0 to infinity
Integration of
derivative of first function
derivative
integration
of t raised to z.
derivative of first means z
T raised to z minus 1 t raised to z minus 1
and integration
into integration of
minus
minus e raised to minus t dt.
dt. So what I will get here? Now this is like this. So if I substitute minus infinity, upper limit will be 0. Minus plus again lower limit also 0 because of this t. Is it? And minus.
Yes, ma'am.
Minus will become
Minus
plus z. Z is independent of t, so outside 0 to infinity e raised to minus t raised to z minus 1 dt. So what I will get here? Z times, this is nothing but my gamma z. Okay.
Gamma.
So gamma z plus 1, I got the relation as z times gamma z. So this is again difference equation. You can see z plus 1 value of that function at z plus 1 is represented in terms of previous values of that function. Okay. Z times gamma z. So this is again
differential equation.
Not differential.
Difference equation.
Difference equation. This is difference equation. Okay. And you might know in factorial notation. What is my gamma 1? What is gamma 1? 0 to infinity e raised to minus t raised to 1 minus 1 is 0 dt. What is this? 0 to infinity e raised to minus t dt. What is this?
dt.
Gamma 1 is
Minus e raised to minus t.
minus t from
Minus e raised to minus t
0 to
0 to
0 to
infinity.
infinity.
what is this?
E minus e raised to
0 to infinity.
0.
plus 0 e raised to
1.
1.
Gamma 1. What is gamma 2? What is gamma 2? It is 2 times
E raised to minus
gamma 1.
1 gamma 1
Sorry,
2
Which is
times
equals to
gamma
2.
sorry, 1 times. Gamma 2. If I want 2 here, Z I have to substitute as 1. 1 times gamma 1. And 1 times 1 is again?
1
1.
1.
What is gamma 3? This
2 times of gamma 1.
times gamma
2 gamma
2 times of
3 times gamma of 2.
gamma 2.
2
is,
2 times gamma 2.
yeah, 2 times gamma 2 means it is 2.
3 times.
2.
Hmm?
3 times gamma.
2 times. 2 times.
Gamma
2
3
times, ma'am.
Z
2 times.
बघा ना, gamma Z plus 1. इथे Z plus 1 आहे. So Z if I substitute as 2, I will get here 3. So 2 times gamma 2. So it is 2 and so on. So what is gamma 4?
3 times gamma 3.
Gamma 3.
Gamma 3, 3 times 2 means it is
6. 6. No.
into 6.
6.
So what is this? This is nothing but
3
3
factorial.
factorial.